Hello, everyone. Please mark your present in the session. If you are live and online, please say hi in the chat window. Hi, Pratibha. Hello, everyone. Okay. Hi, Jay. Chinu, Vandana. Okay, so I hope that we can start today's session. हम लोग आज का सेशन स्टार्ट कर सकते हैं if you guys are online and live. Okay. Great. So good. So in today's session we will be discussing about theory of computation. So theory of computation को हम लोग बिल्कुल बेसिक से लेकर चलेंगे and if you have any doubts you can ask your doubts in the chat window. I can read your chats. तो आप सभी की chats में पढ़ सकता हूँ. Okay. And so again because we are starting तो हम लोग बेसिक से ही लेकर चलेंगे. दो चीज़ें हैं. There are two important things that is important. One is because the examination is very close, तो इसी वजह से मैं theory of computation है I'll be covering in a manner कि आपको सब कुछ समझ में आया है. You will be able to solve every question in the examination. At the same time हम लोग कोशिश करेंगे कि हम जो classes हैं वो उसके अंदर previous year क्वेश्चन ज़्यादा कवर कर सकें. So those students who have taken the courses, you can also watch the same classes in the pre-recorded videos. वहाँ पर भी आप इसको देख सकते हैं. But again we'll be doing these classes every day. और because in the past 10 days I was not available, हम लोग क्लास नहीं कर पाए थे. So I'm going to make up for that time. तो हमारी जो classes होंगी, most of these classes are going to be long classes every day, at least 5 to 6 hours की classes हमारी रहेगी live. And so let us start. Okay. So as the name suggests, the name is theory of computation, right? So it is TOC. In short, we say it is as TOC. And in some colleges, they are also called as automata. TOC as well as automata. So automata is derived from the word automaton and automaton is derived from the word automation. तो हम लोग इस सब्जेक्ट में कर क्या रहे हैं? So सबसे पहले आप सभी आंसर कीजिए चैट विंडो कि हम लोग इस सब्जेक्ट में कर क्या रहे हैं. Why do you even study this subject? हम इस सब्जेक्ट को पढ़ते क्यों हैं? Why do you even study theory of computation? So let us discuss the time later on. सबसे पहले let us start the subject, let us start the topic. और वो सब चीज़ें हम लोग धीरे धीरे अपडेट कर देंगे in the sessions as well as in the community tab also. तो so why do we even start? Why do we even study theory of computation? वंदना, प्रतिभा, जय. theory of computation का मतलब क्या है? Why do you even study theory of computation? TOC हम पढ़ते क्यों हैं? To understand the behavior of machine. That is not correct. So we are not studying TOC to understand the behavior of machine. Machines का behavior समझने के लिए हम TOC नहीं पढ़ते हैं. Okay, so just for everyone, because some of you are joining the session for the very first time. So why do you? What we'll do is every sentence that I'm going to say, I'm going to repeat every sentence in English as well as in Hindi. So हर एक sentence को हम bilingual में करेंगे, हिंदी में भी करेंगे और English में भी करेंगे, so that it becomes easy for everyone to understand. No, we do not study TOC to design machines. हम TOC को machines design करने के लिए नहीं study करते हैं. प्रतिभा, do you have? Hi Mary. So what is theory of computation? देखो यहाँ पर we have two words. One is theory and second one is computation. And this computation is mostly related to mathematics. Okay. And this automata is related to automation. And I think you already know the meaning of the word theory. आप सभी को theory का meaning जो है वो already पता है. So basically here we try to understand what are the mathematical models and how the machines can solve the problem. Theory of computation जो है, in that subject we try and understand कि machines जो है वो problems को कैसे solve करती है. We try to do more research on this topic and we try to formulate some kind of mathematical model which will be able to solve more problems and more computations can be done. So we also try to understand what is the limitations of the computation. जैसे कि हमारे पास here we are going to study various different automatas. For example, we have finite automata, we have push down automata, we have linear bound automata, and we have Turing machine. Now these Turing machines as powerful as your modern day computers. जो आपके Turing machines हैं वो आपके modern day computers जितनी ही powerful है. But again, if you know that Turing machines are as powerful as a modern day computer, then can you design a machine which is even more powerful than your Turing machine? क्या आप कोई ऐसी मशीन बना सकते हैं जो Turing machine से भी ज़्यादा powerful है, right? So we try to do more research on this topic कि किस तरह की problems हैं, what are the categories of problems, what are the types of problems, and what are the different mathematical models जो already exist करते हैं, which already exist to solve these problems. ऐसे कौन से mathematical models हैं जो already exist करते हैं इन problems को solve करने के लिए. And after that again we try to understand if for a certain model we can solve these problems and what is the limitation of that model. Then again how can a new model be proposed, then what will be the limitations of that problem, that model, वो models किस तरह की problems को solve कर सकता है. Again we can see third kind of model, and again we'll try to understand किस model की limitations क्या है. In the end we'll be studying Turing machines, and we know that Turing machines are as powerful as your modern day computers. So can you design a machine, can you formulate a machine which is even more powerful than Turing machine? That means अगर आप एक ऐसी machine बना सकते हैं which is even more powerful than a Turing machine, that means you will be able to solve more problems. इसका मतलब है आप और भी ज़्यादा problems को solve कर सकते हैं. This is what we are trying to achieve. This is what we are trying to do. Okay. So here here again हम लोग जो यहाँ पर स्टडी करेंगे मशीन्स और मैथमेटिकल प्रॉब्लम्स के बारे में डिस्कस करेंगे. तो here let us see the syllabus of the subject. So first of all we will be looking at what is the basics. So in basics we will understand what is the basic of a language. So language के basics क्या होते हैं. Then again we will be seeing what are grammars. And then again we'll be seeing an example of a machine. Okay, and then we'll be starting with DFAs, which is also called as deterministic finite automatas. And after DFAs we'll be discussing about NFAs, which is non-deterministic finite automatas, and there are various problems related to both of them. हम लोग स्टडी करेंगे कि DFAs क्या होता है, NFAs क्या होता है, and again what are the different models related to them, and how can you convert a DFA to NFA, how can you convert an NFA to DFA. There are a lot of things that we are going to study in between. And after this we will be discussing about your push down automata, which is also called as PDA. And then we'll be discussing about what are regular languages and what are regular expressions. And then conversions, there are various conversions will be there. So conversions like how can you convert a regular expression to a finite automata, and how can you convert a finite automata to the regular expression. So these things we are going to discuss in this conversions. And then we'll be also checking out this push down automata and the languages accepted by push down automata, which is your context free language. So we'll have a complete discussion regarding context free language, we'll have a complete discussion regarding context free grammar. And also because we have discussed about this DFAs, we'll also discuss about the regular grammar, we'll also discuss about the context sensitive grammar, and then we will also discuss about the recursively enumerable languages. Then we'll be having the recursive languages. Then we'll have a discussion regarding your type 0 languages. So we'll have more discussions regarding all of them, right? So So here we have unrestricted grammar also, which is your type 0 grammar, and so on. There are a lot of things that we'll be discussing. Okay, so because we are discussing context sensitive grammar, so we'll also discuss about context sensitive languages. Okay, and after this we'll check out what is a Turing machine. So Turing machines क्या होती हैं, and what are the limitations of Turing machines, and what is a linear bound automata. So linear bound automata, and after this linear bound automata we'll also discuss about the computability as well as decidability. हम लोग computability और decidability के बारे में डिस्कस करेंगे. So this topic is very important. I'll discuss what are the topics which are important or the topics that you can leave. So if you look at all of these topics, अगर आप topic number 1 से लेकर topic number 8 तक देखेंगे, these topics are very important for UGC NET. So UGC NET के अंदर from topic number 1 to 8 they ask many questions, but they do not really ask a lot of questions regarding this unrestricted grammar. They do not ask questions into recursively enumerable languages or recursive languages. So उनसे ज़्यादा questions आपके पास नहीं आते हैं. And before this recent time, I mean till 2017, 2018, they do not used to ask questions based on decidability and computability. तो 2007 और 2008, 2017 और 2018 से पहले आपके पास computability and decidability के ऊपर ज़्यादा questions UGC NET में नहीं आते हैं. And still, if you check in the previous 2 years, they asked very few questions related to the computability and decidability. So this will be kind of an optional topic. So if you want to cover this computability and decidability, I will cover it here. But again, that is your choice if you want to leave this topic or not. That is completely your choice. So we will be discussing from the very basics. What is the basics of a language, and what exactly is a language? What is a grammar? Grammar क्या होता है? Language क्या होता है? And what are different machines? तो ये सब चीज़ें हम लोग डिस्कस करेंगे. So during the class, I expect all of you to bring some notebooks and pen. आप जो भी मैं कराऊंगा, so because for other subjects, Pratibha, Jay, I have given presentations and PPTs. So in this subject, I'm not going to give any presentations and PPT. यहाँ पर मैं presentations और PPTs नहीं दूंगा. So I'm going to dictate something, या फिर मैं बोर्ड पर कुछ आपको लिखवाऊंगा. So I expect कि वो सभी चीज़ें आप अपनी नोटबुक के अंदर साथ साथ नोट डाउन करेंगे. So it is better कि आप उसको नोट डाउन करें. Okay. So if you guys are ready, we can start. Can you just write in the chat window that you guys are ready? आप सभी ready हैं और हम लोग start कर सकते हैं. अगर आप इसको नोट डाउन कर लेते हैं, so as soon as something is written, so before deleting or before rubbing my board, तो मैं आपको बताऊंगा कि आप इसको नोट डाउन करें. I mean I'll give you enough time to note down. So while I'm teaching, you can note it down obviously, but again before rubbing my board, I will give you time कि आप इसको नोट डाउन कर सके. आप इसको नोट डाउन करने के बाद just write in the chat window that done, and we can continue. Ready to fly? Okay, good. Great. Fine. Okay, fine. So let us first understand with the layman perspective कि language क्या होती है. तो हम लोग सबसे पहले बेसिक से लेकर चलेंगे. हम लोग बहुत ज़्यादा इन डेप्थ में ऐसे कवर नहीं करेंगे कि आपको प्रॉब्लम हो समझने के लिए. तो मैं सबसे पहले बिल्कुल बेसिक से लेकर चलूँगा और धीरे धीरे हम डिफिकल्ट टॉपिक्स को भी कवर करेंगे. ठीक है. तो सबसे पहला आपका टॉपिक है वी शुड नो व्हाट इज अ लैंग्वेज. तो लैंग्वेज होती क्या है? सो language is a medium through which you can communicate with someone, right? So either you want to communicate with a human being, or you want to communicate with a machine, or you want to communicate with you want to give some kind of instructions. You always need a language for this, right? जैसे कि आप अगर हम लोग human understandable format की बात करते हैं, I am speaking to you, so I am speaking in a English language. Also I can speak in a Hindi language. So this is a human understandable language. But when you are communicating with your computer system, then you cannot communicate in the English language, या फिर जो हमारे पास हिंदी लैंग्वेज में है हम इस तरीके से कंप्यूटर सिस्टम के साथ कम्युनिकेट नहीं कर सकते हैं. Why you cannot communicate with the computer system in this language? इस लैंग्वेज में आप अपने कंप्यूटर सिस्टम के साथ कम्युनिकेट क्यों नहीं कर सकते? There are two major reasons. पहला रीजन ये है that your languages are ambiguous. आपकी जो लैंग्वेज है वो ambiguous है. And secondly, your languages are context sensitive. आपकी जो लैंग्वेज है वो context sensitive है. These are two very big reasons. That is why, because of these two reasons, you cannot communicate with your computer system in these languages. For example, जैसे कि अगर मैं बोलता हूँ, if I say you are hot, what do you mean by this? You are hot, right? इसका मतलब क्या है? इसका मतलब है if you speak to someone, right? So if I'm speaking to you, you are hot. It means either it means कि आपका temperature काफी high है, your temperature is high, right? Maybe you are having fever. If you are having fever, obviously you are hot, right? Or you are hot in looking, correct? So एक sentence के you have two meanings. There are two meanings of this sentence. In the same way, if I say you are very sweet, अगर मैं बोलता हूं कि आप बहुत स्वीट है, यू आर वेरी वेरी स्वीट, इसका मतलब क्या है? आप खाने में स्वीट है, यू आर स्वीट बिकॉज आई कैन ईट यू एंड आई फील दैट यू आर स्वीट, और यू आर स्वीट बिकॉज ऑफ योर नेचर, राइट? So this sentence is having two meanings. This sentence is having two meanings. So in the same way, there are so many sentences in English language where each sentences are having lot of different meanings. काफी ऐसे sentences है जिनके अलग-अलग meanings हो सकते हैं. Now because the sentences are having different meanings, this makes these kind of sentences as ambiguous. So what is ambiguous? Ambiguous means something that creates confusion. ऐसा कुछ जो confusion को create करे उसको हम बोलते हैं ambiguous. So इस तरीके से आपकी जो languages है, the languages that we are saying, this is very very different, right? Now secondly, your languages are context sensitive also. Context sensitive यानी कि आप किस context में बात कर रहे हैं, your meaning of the sentence changes. For example, here if you say you are very very sweet, right? So this is a context. If you are saying you are very sweet to a dish, so that means the dish is sweet in terms of eating. As well as if you are saying the same sentence to a human being, that means that the person is having a very good nature, correct? So this is the reason why there's some kind of context sensitivity. In the same way, let us suppose a male is coming or a man is coming. So we'll say he is coming, right? He is coming. He is coming. वो आ रहा है. और she is coming. The kind of person is coming. This word is also changing. He is changed to she. तो इस तरीके से आप देख सकते हैं that your each and every word or lot of sentences are there where we discuss about context, कि किस context में बात कर रहे हैं, किस बारे में बात कर रहे हैं. तो context की वजह से sentence का meaning change हो जाता है. Context की वजह से we also change the words that we use in the sentence. So this is a very very big reason why you cannot use these sentences for giving instructions to a computer system, because a computer system needs precise instructions. So these are not precise. These instructions are not precise. ये जो instruction है वो precise नहीं है, and your computer system needs precise instructions, right? So it's a very there's a huge difference here. तो हमें चाहिए, so we need a language where we can give precise instructions. So even if you say every language of the world, 99.9% languages of the world that is used to communicate, so these languages are ambiguous. So the most precise language that we have in the entire universe, which can be used for human communication, is Sanskrit. So this is something that you can be proud of, कि जो संस्कृत language है, it is the most precise language in the universe. So you can even use Sanskrit language to do computer programming in the computer system. आप इसको use कर सकते हैं, correct? Now, so what we need is, we need some kind of language. We need some language to give instructions. To give instructions. So ये instructions आप किसको देंगे? So you are going to give these instructions to a computer system. You might be giving these instructions to a mathematical model, you might be giving these instructions to a machine. तो आप किसी को भी instructions देंगे, for that you need some kind of language. Okay, and we are going to discuss about these languages only. So what are the various properties of a language, language की properties क्या होती है, and how can you formulate a language. There are a lot of things that we are going to study here. Okay, so I'm going to rub it. You want to write it down? अगर आपने इसको लिख लिया, just write done in the chat window if you have written it. So I'm going to rub it. Good. आज जय और प्रतिभा को बहुत मजा आ रहा होगा क्लास करते हुए. So, right. So, if I say that we are going to design a language, now there are various building blocks of a language. Building blocks of a language. So, first of all, for every language, we are going to define something called as alphabets of the language. So, let us suppose we have an English language. For that, alphabet is A, B, C, up to so on Z. For Hindi language, we have alphabet as K, up to so on. I don't know what is the last character. So we have alphabets here, right? And with the help of these alphabets, we create something called as a words. So in English, we have he, she, they, except, right? We have a lot of words which are present. So Hindi mein we have different words like khana, gana, and so on. There are a lot of words in Hindi language as well as in English language. Now we use something called as a grammar here to create sentences. To create sentences here. Okay. तो आप यहाँ पर किसी ग्रामर का यूज करते हैं सेंटेंसेस को बनाने के लिए. सो फॉर एग्जाम्पल सेंटेंसेस कैन बी ही इज वेरी स्वीट. सो दिस इज अ सेंटेंस. ओके, सो दिस ग्रामर हियर इट गिव्स रूल्स एंड रेगुलेशंस. So this grammar gives rules and regulations. That means how can you combine these words to create meaningful sentences. So these sentences should be having some kind of meaning. So that means we have a few important things here. So first of all, we have an alphabet, and with the help of these alphabets, I'm going to create some words which are valid combinations of alphabet. Words are valid combinations of alphabet. For example, if I say combination as I, P, some combination, so basically this combination might not be a valid combination. If I say the combination as X, Y, Z, so this is not a valid combination. So in every language, there are some combinations which are valid and there are some combinations which are invalid. So these valid combinations create a valid word. And we combine these words with the help of a grammar so that we can create meaningful sentences, and these sentences are also called as strings. हम इन sentences को यहाँ पर strings भी बोलते हैं. Clear? Now, when I say I need a programming language or I need a new language which should be mathematically precise. Which should be मैथमेटिकली प्रिसाइज. हमें एक ऐसी लैंग्वेज चाहिए जो मैथमेटिकली प्रिसाइज हो. सो इफ यू नीड अ लैंग्वेज व्हिच इज मैथमेटिकली प्रिसाइज, फॉर दैट अगेन वी हैव टू अंडरस्टैंड व्हाट आर द अल्फाबेट्स इन द लैंग्वेज. We have to understand what are the alphabets in the language, and then we have to understand a way to create valid strings. We have to understand a way to create valid strings. And we have to understand a way to define a grammar for it. तो इसके लिए हमें कुछ बताना पड़ेगा जो कि बताएगा कि इसके लिए ग्रामर वैलिड क्या है. ओके, लेट मी गिव एन एग्जांपल हियर. इफ आई से वी हैव C language. if you have a C language, so C itself is a language. So in a C language you have some valid alphabets. और यहाँ पर कुछ ऐसे reserved words है. We have reserved words in C language. तो reserved words कौन से आपके पास? You have a word int, you have a word for, you have a word while, you have a word break, you have a word if, you have a word else. इस तरीके से in C language you have total of 32 reserved words. So these reserved words are basically some valid combinations, and with the help of these reserved words you create a sentence, right? And here the sentence is represented by a program. So that means if I say we have this main function, and here I have integer a, we have integer b, we are going to do a is equal to 5 plus 6, we are going to do b is equal to a plus 11, right? So if I write a program in C language, तो ये जो पूरा आपका प्रोग्राम है, this entire program is a string. This entire program is a string. So what we have done is, so first of all we define what are the important, or you can say reserved word in the language, right? और reserved words को here you can also equate them in the form of an alphabet. आप इन reserved word को एक तरीके से alphabet के साथ भी equate कर सकते हैं. Now we created something called as a grammar here, and in C language what is a grammar? तो C language grammar क्या है? Something that defines what will be the structure of the program. C language अगर हम किसी प्रोग्राम का स्ट्रक्चर को डिफाइन करते हैं, that structure defines a grammar. अब यहाँ पर ये जो पूरा एक प्रोग्राम आपके बना है C language का, now this entire program is a string, and how can you say this program is valid? So to say that this program is valid, so using this grammar, if you can make it, अगर आप इस ग्रामर के साथ इस प्रोग्राम को बना सकते हैं, then we say that this program is valid. So अब हमारे पास दो कॉन्सेप्ट यहाँ पर आते हैं. How can you identify the words are valid or not? आप किस तरीके से आइडेंटिफाई करेंगे कि आपके पास जो वर्ड्स हैं वो वैलिड है या नहीं है? एंड सेकेंडली, हाउ कैन यू क्रिएट दिस ग्रामर, जिससे आप इस वैलिड सेंटेंस को क्रिएट कर सकें. अब देखो, व्हाट वी आर गोइंग टू डू इज, वी आर गोइंग टू हैव टू कॉन्सेप्ट्स हियर, व्हिच इज योर ऑटोमेटास. The concepts are your automatas. So automata is a machine जिसके अंदर if you are going to give a string, so it is going to tell whether the string is valid or the string is invalid. तो automata बताएगा कि जो भी string आप इसको देंगे वो string valid है या फिर वो string invalid है. And these grammars will be used to create strings. ये जो grammar है वो strings create करने के लिए use होती है. Okay? इतना समझ आया सबको? Please write it down. Whatever written on the board, you can write it down. And after writing down, please write done in the chat window. Done. Good. So let me rub it up. तो लेट अस सी ईच ऑफ दीज थिंग्स वन बाय वन. तो हम लोग सब कुछ चेक करेंगे. हाउ कैन यू से अ प्रोग्राम इज वैलिड, और यू कैन से हाउ कैन यू से अ स्ट्रिंग इज वैलिड और नॉट. सो वी आर गोइंग टू डिस्कस ईच एंड एवरीथिंग वन बाय वन. तो सबसे पहले स्टार्ट करते हैं. अभी हम लोग थोड़ा सा जोश में आ जाते हैं, बिकॉज जितना क्लास स्लो होगी उतना जोश खत्म हो जाएगा. तो सबसे पहले जोश में आ जाते हैं, राइट. तो फर्स्ट थिंग इज यू हैव टू डिफाइन व्हाट आर द अल्फाबेट्स ऑफ द लैंग्वेज. तो सबसे पहले आप अल्फाबेट्स को डिफाइन करेंगे, करेक्ट. तो we can say we have an English language. So in English language you have alphabets from capital A, capital B up to so on capital Z. ये सभी आपके पास alphabets है English language में. You can also have alphabets in your own language. So if I'm going to create my own language, so in this language I can say I have one alphabet. आपके पास सिर्फ एक अल्फाबेट हो सकता है. You can also have 2 alphabets, you can have 3 alphabets, you can have any number of alphabets. So this set of alphabets जो इस language के अंदर है, I'm going to represent this set of alphabet using summation. So if I say summation is equal to A, B up to so on Z, that means this is the set of all the possible alphabets in the language. So here you can say this represents what is the cardinality of summation, right? This is a set representation. This is a set representation and this represents the cardinality of this. So cardinality of this set for English language is 26. English language में आपके पास 26 alphabets है. Now if I say that we have summation is equal to small a, that means in my language I have only one alphabet. If I say summation is equal to a comma b, that means in my language we have 2 alphabets. If I say summation is equal to a comma b comma c, in my language I have 3 alphabets. If I say summation is equal to 0 comma 1, that means again in my language we have 2 alphabets. Now if you look at clearly, अगर आप इसको थोड़ा सा ध्यान से देखेंगे, so these are 0 and 1, these are binary numbers. So any computer program, they will be in return converted to binary. So जितने भी computer program है, they are at the last, all these programs are converted to binary. So basically computer only understand a language where you have only 2 alphabets, which is alphabet 0 as well as your alphabet 1. And we know that every possible symbol, every possible instruction, everything we can basically define using these 2 alphabets for computer language. कंप्यूटर जो है उसको अगर आप कोई भी इंस्ट्रक्शंस देंगे, एवरीथिंग कैन बी कन्वर्टेड विद जीरोज एंड वन. कंप्यूटर्स को आप जो भी इंस्ट्रक्शन देंगे वो हमेशा बाइनरी में होगी. सो एवरी इंस्ट्रक्शन दैट यू आर गोइंग टू गिव इन अ कंप्यूटर, दैट इज गोइंग टू बी अ बाइनरी इंस्ट्रक्शंस, एंड कंप्यूटर अंडरस्टैंड्स अ बाइनरी लैंग्वेज, राइट. तो जो कंप्यूटर है वो आपकी बाइनरी लैंग्वेज को समझता है. Fine. So it means there is no limitations that how many alphabets you want to use. You can use 1 alphabet for a language, you can use 2 alphabets for a language, you can use 3 alphabets for a language, you can use any number of alphabets for your language. आप कितने भी alphabets अपनी language में use कर सकते हैं. So if I say we have summation is equal to 0 comma 1, that means it is representing the set of alphabets in my language. Okay. Now if I say that summation cross summation, so summation cross summation is cross product of a set with itself. अगर मैं summation cross summation लेता हूँ तो इससे हमें क्या मिलेगा? That will be 0 comma 1 cross 0 comma 1, which is equal to 0 0 0 1 1 0 and 1 1, and this is represented by summation square. अगर आप इसको ध्यान से देखेंगे, दिस इज सेट ऑफ ऑल बाइनरी स्ट्रिंग्स हुज लेंथ इज 2. इट इज अ बाइनरी स्ट्रिंग, it is a binary string, it is a binary string, and it is a binary string. So this is a set of all possible binary string whose length is actually 2. If I say summation raised to power 3, it means summation square cross summation, or summation cross summation square, or summation cross summation cross summation. So summation raised to power 3 का मतलब क्या है? When you are going to perform this multiplication, when you are going to do this cross product, you are going to get all the possible strings whose length is actually 3. So your possible strings are going to be 0 0 0 0 0 1 0 1 0 0 1 1 1 0 0 1 0 1 1 1 0 and 1 1 1. This is a set of all possible strings whose length is actually 3. Now if I say we have summation raised to power 4, so summation raised to power 4 is going to be set of all possible strings whose length is 4. So which can be 0 0 0 0 0 0 0 1 0 0 1 0 0 0 1 1 and so on, and the last will be 1 1 1 1. So this is a set of all possible strings whose length is 4. In the same way I can say summation raised to power 5, set of all possible strings whose length is 5. Summation raised to power 6, set of all possible strings whose length is 6, and so on. Okay. Now there's one more special summation here, that's summation raised to power 0. So summation raised to power 0 means it is a set of all possible strings whose length is actually 0, and we say that this is epsilon. So कुछ बुक्स के अंदर this summation raised to power 0 is represented by epsilon. In some books this summation raised to power 0 is represented by lambda. तो summation raised to power 0 जो है वो epsilon से भी रिप्रेजेंट करते हैं हम उसको, और उसको हम लोग lambda से भी रिप्रेजेंट करते हैं. So if I take the powers of summation, इसका मतलब है हमें वो सभी strings मिलेगी जिनकी length है. जैसे summation raised to power 3 means length of all set of all possible strings of length 3. Summation raised to power 4 means set of all possible strings of length 4. Now if I do a union of all of them, that is if I do summation raised to power 0 union summation raised to power 1 union summation raised to power 2 union summation raised to power 2 up to so on till infinity. So set of every summation, so this is going to be epsilon comma 0 comma 1 comma 0 0 0 1 1 0 up to so on, it will continue till infinity. So basically if I take this infinite union, यहाँ पर जितने भी summations की power exist करती है, if I take an infinite union, so this will be set of all possible strings over a given alphabet, and this will be represented by summation star. So I just write star like this, summation star. So summation star means set of all possible strings over a given alphabet. Summation star means set of all possible strings over a given alphabet. अगर यहाँ पर हमारे पास in this language we had two alphabets which is 0 and 1, आपके पास सिर्फ दो ही अल्फाबेट थे 0 और 1, तो अगर हम summation raised to power 2 बोलते हैं तो यहाँ पर अब आपके पास वो सभी strings आएंगे जो कि 2 लेंथ की है. तो उसी तरीके से अब मैं इस केस में अगर चेक करूंगा, if I take summation star, तो यहाँ से जितने भी possible strings हैं with zeros and 1, each of those strings, each and every one of those strings can be formulated. जितने भी possible strings हैं वो सभी strings यहाँ पर formulate की जा सकती है. Is it clear? क्या आप सभी के साथ ये क्लियर है? Do anyone of you have any doubts? क्या किसी को कोई डाउट है यहाँ पर? Good. So no doubts. That's good. Correct. Now इस केस में for a language, एक लैंग्वेज में we say that all of these strings, जितनी भी string possible है, all of these strings are not valid. Okay, जैसे कि if I take an example, so for English language the set of summation is A to Z, correct? So for this language, what is summation star for English language? Summation star can be epsilon single A single B up to so on single Z, then AA AB up to so on AZ, then BA BB up to so on BZ up to so on, then we can have 3 length strings and so on, right? So we can have infinite set. अब ये जो infinite set है, there are some strings which are valid for English language and there are some strings which are not valid. इसमें से कुछ ऐसी strings हैं जो कि valid है और कुछ ऐसी strings हैं जो कि valid नहीं है. Okay, so for that we have to define the language. So for English language, because English language is huge, but still the number of words in English language is defined. जो English language है वो आपके पास finite है. Your English language is finite in terms of words. कि जितने भी वर्ड्स इंग्लिश लैंग्वेज में एग्जिस्ट करते हैं, यू कैन काउंट एवरी पॉसिबल वर्ड. ऐसा नहीं है कि इंग्लिश लैंग्वेज इनफाइनाइट वर्ड है. नंबर ऑफ वर्ड्स इन इंग्लिश लैंग्वेज इज फाइनाइट, बट अगेन यू कैन क्रिएट इनफाइनाइटली डिफरेंट सेंटेंसेस विद द हेल्प ऑफ दोज वर्ड्स. आप उन वर्ड्स की हेल्प से इनफाइनाइट अलग अलग सेंटेंसेस को क्रिएट कर सकते हैं. सो इंग्लिश लैंग्वेज हियर is your finite language, it is not infinite. So again we can define for our language how many words can be there in the language. उस words में strings कितनी हो सकती है. आप उसको strings कहेंगे, words कहेंगे, anything that you like. So I'm just going to call it as a string. So I'm going to say how many strings will be there in a language. Okay, please note it down. इसको note down कर लीजिए. Okay, somebody was asking me, sir, how can English language be finite? Okay, so let me just give you some facts, statistics. Maybe you will find these facts and statistics as interesting. If you see Spanish language, in Spanish language there are approximately 1 lakh words. Spanish language में 1 lakh words हैं. In German language we have approximately 1,35,000 words. And in Russian language you have 2 lakh words. You have 2 lakh words approx. And if you look at Italian, we have 2,70,000 words. French is also having 1 lakh words. And in Korean and Japanese language they have 5 lakh words. Korean और Japanese language में लगभग 5 lakh words हैं. Okay? और जो English language है approximately 1 million words are there in English language. जो English की Oxford dictionary है, so in Oxford dictionary of English, so that Oxford dictionary is using 1,71,000 something वर्ड्स इन इंग्लिश लैंग्वेज. ऑक्सफोर्ड डिक्शनरी जो इंग्लिश की है उसमें जितने भी पॉसिबल वर्ड्स हैं इंग्लिश के अंदर वो सभी डिफाइंड होते हैं. एंड ऑक्सफोर्ड डिक्शनरी हैव 1,71,000, इफ आई वांट टू बी करेक्ट इट इज 71,476 वर्ड्स. आपके पास ऑक्सफोर्ड में 1,71,476 वर्ड है. एंड द वर्ल्ड्स लार्जेस्ट डिक्शनरी जो इंग्लिश लैंग्वेज की है दैट इज हैविंग 4,70,000 वर्ड्स. तो बेसिकली जो भी ज़्यादा लैंग्वेज है वर्ल्ड की, so all of them are having less than 5 lakh words. और if you see in English language जो हमारे डे टू डे कम्युनिकेशन के लिए हम लोग यूज़ करते हैं, we use approximately 1.7% of the words जो इंग्लिश लैंग्वेज में एग्जिस्ट करते हैं उसमें से हम सिर्फ 1.7% वर्ड्स को ही यूज़ करते हैं. So you can clearly see that even your English language and each of these languages they are finite. These languages are not infinite. तो ये languages infinite नहीं है. So let us take a few examples here. If I say summation is equal to 0,1, okay, so that means we have only 2 alphabets in our language. Now if I say summation star, so summation star is going to be epsilon, single 0, single 1, 0 0, 0 1, 1 0, 1 1, up to so on till infinity. Okay, so summation star के अंदर there are infinite number of combinations. Now we can define languages. तो हम लोग अपनी languages को define कर सकते हैं and we can define them mathematically. So we can define mathematical languages here. So why I am saying that we are defining languages mathematically, languages को mathematically क्यों define कर रहे हैं? The reason is very very simple कि अगर आपकी languages mathematically precise होगी then your machines will be able to understand the language very easily. आपकी जो machines हैं वो languages को बहुत easily समझ पाएंगी. Okay, so if I say my language is mathematically defined, so I can say let us suppose we have language L1 and this language L1 is a set of all strings of length 2 over summation is equal to a comma b. तो हमारे पास वो सभी स्ट्रिंग्स जिसकी लेंथ 2 है वो यहाँ पर आ जाती है. एंड दिस कैन ऑल्सो बी रिटन एज L1 is equal to W such that length of W is equal to 2 and W belongs to summation star. तो आप सेम लैंग्वेज को मैथमेटिकली इस तरीके से भी डिफाइन कर सकते हैं. सो दिस इज बेसिकली अ सेट बिल्डर फॉर्म. ये आपकी एक सेट बिल्डर फॉर्म है. ठीक है, एंड दिस इज जस्ट अ डिस्क्रिप्टिव फॉर्म. ओके, as well as we can also give the exact strings that are present in this language. तो हमारे पास if I say that we have two symbols which is 0 and 1, so what are the strings which can be formulated using this? तो कौन कौन सी string है आपके पास यहाँ पर? So the strings can be 0 0, 0 1, 1 0 and 1 1. So these are every possible string whose length is exactly 2. Okay. So ये जो strings हैं इन सब की length जो है वो exactly 2 है. In the same way, I can say that W such that length of W is equal to 3, and or you can say less than equal to 3, and W belongs to summation star. तो यानी कि वो सभी strings, every possible string whose length is less than or equal to 3 are present in this language. So for this language L2, what are the strings that are possible? The strings can be epsilon, 0, 1, 0 0, 0 1, 1 0, 1 1, 0 0 0, 0 0 1, 0 1 0, 0 1 1, 1 0 0, 1 0 1, 1 1 0 and 1 1 1. Okay. Now if you see the cardinality of L2, तो L2 की cardinality कितनी? Cardinality means what are the number of strings here. So how many strings are present in L2 language? 1 2 3 4 5 6 7 8 9 10 11 12 13 14 and 15. So there are total of 15 strings which are present in the language L2. Okay. I can also say that a language L3 means set of all even length strings. जितनी भी जो strings है जिनकी लेंथ even है वो सभी इस लैंग्वेज के अंदर आती है. ठीक है. So I can also represent like this: L3 is equal to W such that length of W mod 2 is equal to 0, and in some books this can also be written as length of W mod 2 is congruent to 0 mod 2, and W belongs to summation star. तो mod 2 मीन्स यानी कि इसकी लेंथ को अगर आप 2 से डिवाइड करेंगे सो रिमाइंडर शुड बी 0. तो अगर इसकी लेंथ 1 है सो 1 डिवाइडेड बाय 2 द रिमाइंडर विल बी 1. 5 डिवाइड बाय 2 द रिमाइंडर विल बी 1, बट 4 डिवाइड बाय 2 द रिमाइंडर विल बी 0. सो दैट मीन्स जितनी भी स्ट्रिंग्स आपकी इवन लेंथ की है वो सभी इस लैंग्वेज के अंदर आती है. सो दिस लैंग्वेज L3 विल बी हैविंग द स्ट्रिंग्स विच आर समीशन 0 0, 0 1, 1 0, 1 1, 4 times 0 up to so on. So जितने भी strings जिनकी length even है, all the strings whose length is even, they come in this language L3. तो L3 language के अंदर आपकी even length की strings आएंगी, even length strings. Okay. Now by looking at all of these examples, you must be confused, sir, what is this epsilon? ये epsilon है क्या? This epsilon is an even length string. This epsilon is a null string or what? देखो, when we have a set which is an empty set, जैसे कि if I say A is equal to like this, right? इसका मतलब क्या है? A is an empty set. Or if I say A is equal to 5, that means A is an empty set. So you have empty brackets or 5. They are used to represent empty set. Okay. If I use brackets and a phi here, it is means a set containing one element, and that element is phi. That element is an empty set. Okay. So if I say B is equal to this, so if I see the cardinality of B, so cardinality of B is going to be 1. But epsilon is not equal to phi, or epsilon is not equal to, or epsilon is not equal to, epsilon is not equal to this empty set. जो एप्सिलॉन है ना तो फाई के इक्वल है और ना ही एप्सिलॉन जो है वो एम्प्टी सेट के इक्वल है. सो क्लियरली यू कैन सी epsilon does not mean that we have an empty set. Epsilon means we have an element whose length is 0. Okay, so if I say we have a set which is containing phi, so this is not an empty set anymore. This is a set which is containing an element whose length is 0. So phi जो है वो सिर्फ length 0 को represent कर रहा है, but it is still an element. ये अभी भी एक element है. So phi this is not equal to this. ये जो है वो इसके equal नहीं है. Why? Because it is a set which is containing another empty set. It is a set which is containing a string of length 0. So string of length 0 is not equal to phi. So we can say epsilon is not equal to phi by this. Epsilon जो है वो phi के equal नहीं है. So we should understand there's a difference between an empty set as well as there's a difference between phi. Now जिस तरीके से English language में we have finite number of words, उसी तरीके से for this language L1 we have finite number of strings. जितनी भी string possible है वो यहाँ पर सिर्फ 4 है. इस language के अंदर there are only 4 strings are possible. Now here you can see for this language L3 there are infinite number of strings are possible. This L3 language is infinite. So you can see cardinality of L3 is infinity because the set of all possible even length strings is infinite. Okay, so ये जो है जो even length strings का जो set है वो infinite होता है. And if you look at this set which is L2, and L2 is a finite set. L2 जो है वो एक finite set है. So Diksha is asking, do we need to add this epsilon in each and every set as first element? No Diksha, it is not necessary to add this epsilon. हर एक set के अंदर हमें epsilon को add करने की ज़रूरत नहीं है. We do not have to add epsilon in each and every set. It is just a language specification. जिस तरह से एक language है उसकी specification होती है. So for a language specification we can say that this is a valid word and this word exists, or this is a valid string. This string exists in the language. Then we can include that string. Right? Let me give you an example. So this is a word Champs Elysees, right? So I don't know if I'm writing the correct spelling. So let me search at it. Right. So it is ELYSEES, right? So this word is not a valid English word. ये एक valid English word नहीं है. Okay, so in English you will read it as Champs Elysees, but in French you will read it as Champs Elysees. French में इस word को हम लोग Champs Elysees बोलते हैं, but in English language we call it as a Champs Elysees. And Champs Elysees is not a valid word in English. English में एक valid word नहीं है, right? But it is a word of French. It is a French language word. Okay, in fact it is a name of a place in France. So Champs-Elysees is a name of a place in France. Okay, so in the same way this word doesn't exist in English, but this word exists in French. So उसी तरीके से we might be having a language which might be having some words which are present, or you can say some strings which are present in the language, and then we might be having some strings which are not present in the language. Okay, please write it down. After writing it out, write done in the chat window. इसको राइट करने के बाद राइट डाउन इन द चैट विंडो. Don't worry Pratibha, you'll understand it more clearly. अभी I'm going to take more examples, तो आपको समझ में आएगा. So right now just remember that this epsilon is a string of length 0. बस इतना सा. You do not have to dig deep right now. वो आपको step by step with examples you will understand. But right now just understand जब हम epsilon बोलते हैं उसका मतलब है उस string की length 0 है. String में सिर्फ एक ही मतलब उस string में कोई भी मतलब उसके अलावा और कोई length नहीं है उसकी. The length is 0. That's it. So you understand if I take more examples तो आपको समझ में आएगा this thing more clearly. Okay, so let's see how many topics we'll be able to cover. I have not formulated the number of topics till now, so let us see how many topics we'll be able to cover today. Okay, so let us look more topics, more things here. So I know now what are the alphabets. I know what are the alphabets, and I know what is the language. So up we have seen an example of the alphabets, and we have seen the example of the language also. Okay. Now after this, we want to understand what is an automata. So I'm just I'm giving an overview right now. Okay, what is the alphabet, what is the language, and what is an automata. I'm just giving an overview. So still I'm going to cover these languages in more details. हम लोग इस language के I think we'll be taking like 100-150 examples of a language. So these things we are going to cover in this subject. But right now I'm just telling you the difference between a language and what is an automata. I'm just telling you the difference. कि ये लोग चीजें हैं क्या? What are these things? Okay. So what is an automata? So automata will be like a mathematical model here, or you can say automata will be like a machine. So it is a mathematical machine, you can say. Okay, so automata is created from the word which is automaton, and this automaton word जो है, it is very much interrelated to automation. Okay, so let us first understand what is an automata. So this is just like a plural and singular form of each other. तो उसमें आपको ज़्यादा deep करने की ज़रूरत नहीं है. Don't have to focus on that. Just try to understand what exactly is this automata. So what is the responsibility of an automata is if you give a string to this automata will say yes, it is a valid string, कि हाँ ये एक valid string है, या फिर it will say no, it is a इनवैलिड स्ट्रिंग. ये जो स्ट्रिंग है ये एक इनवैलिड स्ट्रिंग है, कि अगर इसको कोई भी स्ट्रिंग आप देंगे वो स्ट्रिंग वैलिड है या फिर नहीं है. दैट विल बी गिवन बाय दिस ऑटोमेटा. ओके, सो लेट अस सी द बेसिक ऑटोमेटा, दैट इज योर फाइनाइट ऑटोमेटा. तो जो है सबसे पहला आपके पास, दिस इज द एग्जांपल ऑफ अ फाइनाइट ऑटोमेटा. सो इन अ फाइनाइट ऑटोमेटा we have something called as a tape. ये आपके पास एक tape है. Now we have a read write head, and we have something called as a finite control, and with this we have a finite memory. Okay, so this is the basic structure of a finite automata. तो finite automata में आपके पास एक tape है, you have a read write head, you have a finite control, and you have a finite memory. Now let me show you with the help of an example. Okay, before that let me just understand this. You must have studied about tape recorders, right? तो आपके पास पहले कभी tape recorder या cassette players हुआ करते थे, cassette players, or you must have seen VCRs, something like this. So these things are very popular in the year 2007, 2005, right? So in 2003, 2004, these cassette players are very important. People used to listen music on these cassette players. Okay, so what used to happen is in these cassettes we used to have something called as a reel like this. Okay, and then some part is here, and we put a read write head here. So whenever you play the music, these reels used to rotate. They go from one direction to another direction, and these reels are basically electromagnetic reels. These are electromagnetic. So all your music data or your audio data, so you used to store in these tapes. इन tapes के अंदर आप म्यूजिक और ऑडियो डेटा को स्टोर करते थे. and your cassette players used a read-write head to read the data from the reel, and they also used this read-write head to write some data on the reel. यानी कि अगर आपको टेप के अंदर, कैसेट के अंदर कुछ रिकॉर्ड करना है या उसमें से कुछ सुनना है, तो उसके लिए हमारे पास ये रीड-राइट हेड हुआ करते थे जो कि उस रील में से रीड करते थे, राइट. In the same way, you can also consider this as a tape. आप इसको भी उसी तरीके से एक टेप की तरह कंसिडर कर सकते हैं. So what you do on this tape is you write your alphabets, right? So you have an alphabet A, you have an alphabet B, or whatever your string is. Maybe this is your string. So you write your string on this tape. आप अपनी जो string है वो इस tape पे लिखेंगे. And each of these cells are going to hold one alphabet. ये जो सभी cell है ये एक alphabet को hold करते हैं. And this finite control is going to read this alphabet from the tape, और read करने के बाद it is going to go in a state. ये एक state पर चला जाएगा. And what exactly this state is? अगर आपने, if you have studied this digital logic, so in digital logic you must have studied about this counters. So for every counter we can create state for a counter. तो counter की states क्या क्या है, and those states are recorded in the cell, right? तो counters जो है, every state can be represented in a counter like a cell, right? So cells are basically of flip flops, which is JK flip flop, SR flip flop, T flip flop, T flip flop, whatever flip flop you are going to use. तो ये in digital logic those flip flops are used to store some data, and those flip flops are used to act as a 1-bit cell. So उसी तरीके से this finite control is going to read some data from the string. ये string का कुछ data को read करेगा. This data can be anything. So this can be written in the strings alphabet जो कि हम बताएंगे. So maybe we can say in our language we have alphabets as A and B. We can say in our language we have alphabets and 0 and 1. अगर I can say that alphabets in the language is A and B, that means I can load the strings of A and B on this tape. If I say the alphabets of the language is 0 and 1, that means I can load this alphabets 0 and 1 on this tape. Okay. तो जो भी आपके लैंग्वेज के अल्फाबेट है, I can create some string and I can load this string on this tape, and then this finite control will say, after reading this entire string, does this finite control reach to a specific state? हम बोलेंगे एक state है हमारे पास, there is one state which is a final state. If this finite control reaches to that final state, then we say that this string is a valid string, otherwise we say that string is a invalid string. अगर एक finite control एक specific valid state पर पहुंचता है तो उस केस में हम बोलेंगे जो string है वो valid है, otherwise वो string invalid है. So just like in digital logic, for counters we created state diagrams. हमने counters के लिए state diagrams भी create किए थे. I think for digital logic you must have studied FSM, which is finite state machines. Okay, so finite state machines means machines which are only having finite number of states. So in the same way here, for every language I'm going to create a machine which is going to be like a finite state machine, similar to this FSM, but again those machines will be having a specific state and we can name that state as final. हम उस state को final बोल सकते हैं. If after reading the string you can go to that final state, that means the string is accepted, यानी कि the string is a valid string. Let me show you with the help of example, then you will be able to understand. एक दो examples के साथ समझाऊंगा तो आपको ज़्यादा better समझ आएगा. So let us say we have summation is equal to 0, 1. हमारी language में we have two alphabets which is 0 and the alphabet 1. And now we are saying the language is W such that length of W mod 2, or make it W such that length of W is equal to 2 and W belongs to summation star. Okay, so that means if I take star of this summation, then star will be length, string of length 0, which is epsilon, string of length 1, strings of length 2, strings of length 3, up to so on, strings of length 4, then again so on till infinity. So there will be infinite number of strings. But in this language L, we have only those strings whose length is exactly 2. हमारे पास सिर्फ वही strings आएंगी जिसकी लेंथ जो है वो exactly 2 है. थोड़ा इसको ध्यान से समझना. Those students जो उसको सब्जेक्ट को पहली बार पढ़ रहे हैं, those students who are studying this subject for the very first time, so please try to understand and focus on this. This might be a little tricky and complicated. So यहाँ पर जो strings आपके पास हैं, so strings can be 0 0, 0 1, 1 0 and 1 1. Okay. Now what do we want to do is, we want to create an automata. We want to create a model of an automata. That means to that model, if you load a string from here, if I load 0 0, now this finite automata should go to a final state and it should say that this string is valid. But if I load a string which is not present in this language, for example, if I say the string is 0 0 0, which is a string of length 3, then this should go to a non-final state. तो ये जो है एक non-final state पर जाएगा. Then we can say that it is a invalid string. तो उस केस में बोलेंगे string is a invalid string. In this case we can say the string is a valid string. Okay. So यहाँ पर those students who have done BTech and MTech, they know finite automatas and they have studied this subject very thoroughly in their BTech, MTech as well as in GATE. But the students who are from MCA or MSc background, so 99% of you have not studied this subject before. तो जो MCA और MSc वाले students हैं, please try and focus on this. तो यहाँ पर how can we create an automata? Let me just show you with the help of a diagram, and then maybe we can practice more on that. Okay. So if I say I can create something like this, this is your initial state, and I am representing this initial state as Q0. ये आपकी जो initial state है मैं उसको Q0 से represent कर रहा हूँ. Okay. Now if I give a string here which is either 0, or if I am giving a 1, then I will go to the state Q1, and again if I give a 0 or if I give a 1, then I will go to the state Q2, and here I am saying that Q2 is a final state, and again if I am giving a 0 or 1, I am going to the state Q3 and I am going to loop here on the state Q3. Okay. So अब यहाँ पर there are two, three things that you need to understand. First of all, if I say something like this, for example Qx, it means I am representing a state. If I am saying something with two circles like this, that means it is representing a final state, right? If I am representing something like with this, that means it is a transition. It is a transition. If I am representing a state with this arrow in the beginning, for example here Q0 is having a beginning arrow which is not from any other arrow, so that means it is a initial state. तो ये आपकी जो है ये एक initial state है. Okay. So here we have 4 states. अब ये काम कैसे करेगा देखो. If I load a string here on this tape, अगर मैं इस tape पे एक string को load करता हूँ, for example the string is 0 and 0. That means after reading the first 0, I'm going to the initial state Q0 to one more state which is Q1. यानी कि आपने पहला 0 पढ़कर आप Q0 से Q1 के पास गए. Now after reading this second 0, आपने second 0 को read किया, that means you are going to the state from Q1 to Q2. आप Q1 से गए Q2 के पास, और उसके बाद जो string है वो आपकी finish हो गई. String is finished. So when your string is finished, then you are now at a final state. अब आप एक final state पर हो. That means this is a valid string. इसका मतलब ये जो है ये एक valid string है. Okay. Now if you look at this string which is 0 0 0, तो सबसे पहले आपने एक 0 दिया. So by this 0 आप Q0 state से Q1 के पास गए. फिर आपने सेकेंड 0 दिया, आप Q1 से लेकर Q2 के पास गए. फिर आपने थर्ड 0 दिया, फिर आप Q2 से लेकर Q3 के पास गए. और उसके बाद स्ट्रिंग फिनिश हो गई, तो यानी कि आफ्टर रीडिंग दिस एंटायर स्ट्रिंग यू आर एट अ स्टेट Q3 एंड दिस Q3 इज नॉट अ फाइनल स्टेट। जो Q3 है वो एक फाइनल स्टेट नहीं है, दैट मीन्स दिस इज नॉट अ वैलिड स्ट्रिंग ऑफ दिस लैंग्वेज। जो स्ट्रिंग है वो इस लैंग्वेज की वैलिड स्ट्रिंग नहीं है। ओके, तो जो स्ट्रिंग है वो इसकी वैलिड स्ट्रिंग नहीं है इस लैंग्वेज में। ओके फाइन, so if I give, see I understood your question Madhuri, but just follow through me, you will understand your doubt very easily। आपका जो डाउट है वो क्लियर हो जाएगा, just follow through it, give it some more time, you will understand it। okay, now let us assume that we have a string here which is 0 1 0 0 and 1। now you can see this string is not present in this language L। ये जो string है वो इस language L में नहीं है। हम what is the length of the string? It is 0 1 2 3 and 4। तो string की जो length है वो है 4 and this language is only containing strings of length 2। so obviously this string does not exist in this language। जो string है वो इस language के अंदर exist नहीं करती। now सबसे पहले हमने सिंबल 0 को रीड किया, that means हम स्टेट Q0 से लेकर Q1 के पास गए। फिर हमने सिंबल 1 को रीड किया, दैट मीन्स हम Q1 से लेकर Q2 के पास गए। फिर हमने सिंबल 0 को रीड किया, यानी कि हम Q2 से लेकर Q3 के पास गए। फिर से हमने सिंबल 0 को रीड किया। नाउ Q3 इज हैविंग अ लूप हियर, यानी अगर Q3 पर एक और 0 आता तो अगेन हम लोग Q3 के पास गए। फिर हमारे पास 1 आया तो अगेन हम लोग Q3 के पास गए। सो बेसिकली Q3 इज हैविंग अ लूप, राइट। सो हियर यू कैन क्लियरली सी दैट if we have a string whose length is more than 6, whose length is more than 7, whose length is more than 8, still this diagram or can this finite state diagram will be able to hold that string also, right। तो ये जो diagram है, I'm calling this diagram as a finite state diagram। इस diagram को हम बोलेंगे finite state diagram। Why? Because the number of states in this diagram is finite। you do not have infinite number of states, you only have finite number of states। how many states are there? There are total 4 states। okay, so this kind of diagram is called as a diagram of a finite machine। it is representing a finite automata। so machine means automata, it is representing a finite automata and this is the diagram of a machine, or you can say it is kind of a block diagram जो कि machine को represent करता है। Is it clear? Pratibha, if we have a deterministic finite automata, then we have to handle all transitions। अगर आपके पास deterministic finite automata है तो उस केस में आपको सभी transitions को handle करना पड़ता है। If you have a non-deterministic finite automata, then maybe you can miss some of the transition। उस केस में आप कुछ transition को भी miss कर पाएंगे। You will understand it more clearly। okay, तो just note it down and write done in the chat window। इसको नोट करने के बाद chat window पे done करिए, लिख दीजिए प्लीज। I will tell everything step by step, just follow through the lectures। I will tell what is a book you can follow, I will tell a lot of things, but step by step। okay, so I've shown you one model of a machine। now we can have different models of machine। so let me just show you some example। we have different models of machines। okay, so the first model is the model of a finite automata। finite automata, so in a finite automata you have a tape here, this is a tape where you can load your string, you have a finite control and you have a finite memory। this memory is finite। so if we have a machine like this, then we call it as a finite automata। तो हम उसको बोलेंगे finite automata। Second, push down automata. So in a push down automata, we replace this finite memory with the help of a stack. So we have a tape like this, where you can load all the symbols, and this is your finite control, and with this finite control we have a stack. And you know the working of a stack can go in one direction, and this is an infinite stack. That means you can store infinite amount of string here. Okay, तो यहाँ पर इस stack के अंदर आप infinite amount of string को store कर सकते हैं. Okay, so you know how the stack works. We have a push operation, we have a pop operation, and so on. So if you, in the finite automata, if you change this finite memory with the stack, then this will be called as a push down automata. So in that case, push down automata. The third one here is a Turing machine. Turing machine. So again, with this Turing machine, we do not really have an infinite memory. So it is same like a finite automata, but slight difference. So this is a tape, this is your finite control, and here again we have a finite memory. And here this special functionality here in a Turing machine. What is the functionality? So look at it carefully. In a finite automata, this read-write head, this is a read-write head, it can go only in one direction. ये सिर्फ एक ही direction में जा सकता है, only in one direction. And secondly, it is just a read head, it is not a write head. So it is just going to read the data from the tape. It is not going to write the data on the tape. In a push down automata, again it is just a read head, and it can only go in one direction. Okay, so theoretically we call it as a read-write head, but practically when we solve problems, so in 99.99% of the problems we say this is only going to read the data from the tape. So maybe there are some model existing where this can also write, but they are not of our use. हम लोग उनको study नहीं करेंगे. There are some research papers also, but they are not of our use whatsoever. So for our case, for our purpose, this finite automata can only read the data from the tape. This can only read the data from the tape, and this can only move in one direction. ये सिर्फ एक ही direction की तरफ move करेगा. This cannot move in more than one directions. Now in case of a Turing machine, this is special case where, because this is a read-write head, this can read as well as this can also write on the tape. And secondly, it can go in both the directions. ये दोनों directions में जा सकता है. Both the directions it can go. Okay, and third, we consider that this tape is an infinite tape. That means it can go in the left direction as much as it wants. It can go in the right direction as much as it wants. There's no limitations whatsoever. It can go up to any amount. ये कितना भी left या right direction में जा सकता है. Okay. Now the fourth one here will be called as your linear bound automata. The fourth one will be linear bound automata. So in a linear bound automata in a Turing machine, there is a very, very slight difference. So what is the difference? So this is a tape. Again, this is your finite control, and this is your finite memory. Okay, and this finite control can go in both the direction. This read-write head can go in both the right direction. It can read as well as it can also write. But the difference is, here in this Turing machine, it can also go beyond the string. I mean to say, let us assume that you have a string ABA. This is the string. So it can go any amount of spaces here. It can also go any amount of spaces here. It is not confined with what is the length of the string. But in a linear bound automata, if this is a string which is ABA, the limitation is this read-write head can go between these two lines. इट कैन नॉट गो बियॉन्ड दिस, ये जो है वो इससे बियॉन्ड नहीं जा सकता, बट हियर इट कैन गो एनी अमाउंट ऑफ स्पेस बियॉन्ड दीज वैल्यूज. ओके, सो ह्यूज डिफरेंस इज देयर in linear bound automata. Okay, so in case of Turing machine, there are a lot of variations of Turing machines, like there are 36, 37 different variations of Turing machine in your syllabus. But again, in examples, in real world theoretical purpose, there are huge number of variations of Turing machines, and we do not really have to study all those variations. So here we are just going to see what are the variations of Turing machine and what are the capabilities. But again, Turing machine is the most powerful machine that is possible and that is known to human till now. Okay, till now no one is able to propose a machine which is more powerful than your Turing machine. कोई भी Turing machine से ज़्यादा powerful machines को propose नहीं कर पाया है. So in our syllabus we'll be studying these 4 machines in complete details. First of all, I'm going to study finite automata. Then we are going to study Turing pushdown automata. Then we are going to study the Turing machines, and then we are going to study the linear bound automata. Okay. Now you can also ask me, sir, which of these machines is more powerful and why do we study all of these machines? हम इन study machines को पढ़ क्यों रहे हैं, और इसमें से जो machines है कौन सी machine ज़्यादा powerful है? So you can ask me this question. Now you can see that first you have this finite automata, then this pushdown automata is more powerful than the finite automata, and then this Turing machine is more powerful, or you can say this linear bound automata is more powerful than pushdown automata, and after this you have the Turing machine, which is the most powerful machine out of all of them. Turing machine जो है इन सबसे ज़्यादा powerful है. And what do you mean by this power? इस power का मतलब क्या? What do you mean by this power? The power means the capability of solving a problem. So it means this pushdown automata can solve more problems as compared to the finite automata, and this linear bound automata can solve more problems as compared to pushdown automata, and this Turing machine can solve more problems as compared to linear bound automata. So सबसे ज़्यादा जो problems हैं वो Turing machine solve कर सकता है as compared to any other machine. तो जितनी भी machine है उन सबसे ज़्यादा जो problems है वो Turing machine ही solve कर सकता है. Okay. So now what we have to do is, first of all we'll study this mathematical model. This is finite automata is a mathematical model. So all of them are basically mathematical model. So we'll start with the finite automata, and there are 2 variations of finite automata, which is deterministic finite automata, as well as we have a non-deterministic finite automata. Again, for pushdown automata we have 2 variations. The first one is your deterministic, and second one is non-deterministic. Okay, so we'll be studying both finite and PDA in complete thorough details, because 80 or you can say 85% of your question in your examination they will come from finite automata and pushdown automata only. आपके 80 से 85% जो क्वेश्चन है एग्जाम में वो सिर्फ finite automata और pushdown automata में से ही आएंगे. Now rest your 5 to 10% of your questions they will come from Turing machine. 5 to 10% of your questions they will come from Turing machine. Or you can say 5, I would say. Why? Because next 5% you can expect from decidability and computability. So 5% questions will come from Turing machine. And again the Turing machine is of type which is deterministic. It is also non-deterministic, but we do not really study non-deterministic here, because deterministic Turing machine is equivalent to as power to non-deterministic. So here we are only going to study deterministic Turing machines. And then we have linear bound automata, and you can see that in your examination you will be having 0% questions from linear bound automata. Nobody really asks any questions on LBA, and LBA is not even in our syllabus whatsoever in that sense. एक तो इसमें से कोई इंटरेस्टेड नहीं है. Nobody asks questions from LBA. They only ask questions from finite, pushdown and Turing machines. Okay, so that was okay, I think you have written it. Let me give you one more overview of the subject. So this is basically an introduction lecture. So what are the things that we are going to study? Let me tell you something else as an overview. just write it down in the chat window, then I can rub it. So in our syllabus we are going to start with the finite automatas only. So in the next lecture I'm going to start with finite automata, but before that let me give you one more overview. Okay, done. Let me rub it. Those who are online, please say hi again in the chat window. जो students online हैं, those who are watching the live streaming, please say hi in the chat window, because I should know how many students are active and how many are not active. Quick and fast. Come on, fast. Everyone, please say hi in the chat window. Good. Now see, there's one more overview. As I told you that initially I'm going to study something about finite automatas. So there are two types of finite automatas. One is your deterministic finite automata and second one is your non-deterministic finite automatas. Okay. So let me show it this way, that this is the set of all finite automatas. ये जितने भी finite automatas exist करते हैं, this is the set of all those finite automatas. Okay. Then if this is the set of all those finite automatas, so this set contains two sets. One is your deterministic finite automata, second is non-deterministic. Then this will be the set of all deterministic push down automata. Okay. And then this is a set of all non-deterministic push down automata. So आप इसको साथ लिख सकते हैं. You can write their full forms also, because these full forms are important. Okay. So we are going to study each of these things in a lot of details in our subject. तो ये सभी full forms सभी के लिए important है. So we have finite automata. Again, there are two types of finite automata, which is deterministic finite automata as well as non-deterministic. But actually, deterministic finite automata is equivalent to power to non-deterministic finite automata. Both are equivalent in power, right? So you'll understand what is the equivalence of power later on. Then we can say deterministic push-down automata. These deterministic push-down automata are more powerful than finite automata. And when I say more powerful, इसका powerful का meaning क्या? What do I mean by powerful? When I say powerful, it means this is having more capability of solving a problem. So if we can propose a model which is more, which can solve more problems, which this cannot solve, we can say it is more powerful. For example, deterministic push-down automata can solve more problems as compared to the finite automata. That is why we can say deterministic push-down automata is more powerful as compared to the finite automata. Okay. And then non-deterministic push-down automata is again more powerful as compared to deterministic push-down automata. ये उससे भी ज़्यादा powerful है. And then we are going to study something called as linear bound automatas. So linear bound automata is much more powerful as compared to non-deterministic push-down automata. And then we have Turing machines. So we have Turing machines. So there are two variations of Turing machines. One is your halting Turing machine, and second one we can say it is just a Turing machine. Fine. So again, Turing machine and halting Turing machine दोनों के केस में we cannot prove which one is more powerful. तो यहाँ पर हम प्रूव नहीं कर सकते, बट जस्ट इमेजिन हियर दैट वी कैन से देयर आर मोर ट्यूरिंग मशीन्स एज कम्पेयर टू हॉटिंग ट्यूरिंग मशीन. So I am just representing it here like this, but because I have to represent few languages also, so here nobody really knows that the Turing machine is more powerful or halting Turing machine is more powerful. Okay, now the languages which are accepted by finite automata, जो finite automata जिन language को accept करते हैं, these languages are called as regular language. These languages are called as regular languages, or you can say you can only create finite automatas for regular languages. आप सिर्फ regular languages के लिए ही finite automata बना सकते हैं. If a language is not regular, then you cannot create a finite automata for this. If I say we can create a deterministic push-down automata, that means we can call it as a deterministic context-free language. For deterministic push-down automata, you can create deterministic context-free language. If we can create a non-deterministic push-down automata, then we can simply call it as a context-free language, or you can say the language is accepted by context-free non-deterministic push-down automata is context-free. तो ये सब चीज़ें आप समझेंगे बाद में लेटर ऑन, हम इन सभी चीज़ों को एक एक करके स्टडी करेंगे, बट राइट नाउ जस्ट कीप इट एज ए इंट्रोडक्शन, मेक दिस डायग्राम इंट्रोडक्शन की तरह से इसको लो, एंड देन वी आर गोइंग टू स्टडी ईच ऑफ दीज थिंग्स इन मोर डिटेल्स इन द अपकमिंग लेक्चर्स. ओके, सो फॉर नॉन डिटर्मिनिस्टिक पुश-डाउन ऑटोमेटा, the languages accepted by them is context-free language, right? So here you can see this deterministic context-free language, it is a bigger set as compared to regular language. That means every regular language is also deterministic context-free, and every deterministic context-free is also context-free. Okay, इसका मतलब क्या है? It means a non-deterministic push-down automata, or simply you can call it as a push-down automata. Push-down automata contains deterministic as well as non-deterministic. So simply you can say a push-down automata can accept a context-free language as well as it can also accept a regular language. So push-down automata is more powerful as compared to your finite automatas. Okay, so when I say push-down automata, it means PDA. It means it can be deterministic push-down automata as well as it can also be non-deterministic push-down automata. So मैं दोनों को एक साथ include करके I can just say it is a push-down automata. Okay, and then the languages accepted by the linear bound automatas, then these languages are called as context sensitive language. जो linear bound automata जिन languages को accept करते हैं, उन languages को हम बोलते हैं context sensitive language. Okay, and the languages accepted by these halting Turing machines, these languages are called as recursive languages. They are called as recursive languages. Okay, and the languages which are accepted by Turing machines, these languages are called as recursively enumerable languages. So it means, what do I mean to say by this is, every regular language is also a context-free language. Every context-free language is also a context-sensitive language. Every context-sensitive language is also a recursive language, and every recursive language is also recursively enumerable language. But every recursively enumerable language is not recursive. Every recursive language is not context-sensitive. Every context-sensitive is not context-free. Every context-free language is not deterministic context-free, and every context-free language is not regular. तो यहाँ पर we have a bigger set and we also have a smaller set. So these are two types of set here. Okay, now there's something called as a grammar. तो यहाँ पर हमारे पास क्या है? We have seen this is an example of all the machines. This is the example of all the languages. Now we have something called as a grammar. So again we have four types of grammar. So first of all we have a type 3 grammar, which is also called as a regular grammar. Okay, so this is for regular languages, we can create the regular grammars. Then we have type 2 grammars, which is also called as context free grammars. We have a context free grammars. Okay, then so context free grammars you can create for context free languages. If a language is context free, whether it is a deterministic context free or whether it is a context free, we can create a context free grammar. Again, there are more partitions like deterministic context free grammar or just context free grammar. वो हम लोग later on discuss करेंगे, right? For context sensitive languages, we have type 1 grammar, and type 1 means it is context sensitive grammar. We have context sensitive grammar. And then for recursively enumerable languages, we have type 0 grammar, and this type 0 grammar is also called as unrestricted grammar. I hope this everything is visible. Just let me have a look. I think yes, it is, everything is visible. Fine. So what do I mean to say by this is, every type 3 grammar is also type 2. यानी कि जितनी भी regular grammar है, all these regular grammars are also context free grammar. Every type 2 grammar is also type 1. That means all context free grammar is also context sensitive. Every type 1 grammar is also type 0 grammar. That means all context sensitive grammar is also unrestricted grammar. But every unrestricted grammar is not context sensitive grammar. Every context sensitive grammar is not context free grammar, and every context free grammar is also not regular grammar. तो सभी context free grammar जो है वो regular नहीं है. Okay. Now what we are going to study in this subject, हम किस तरीके से follow करेंगे, how we are going to follow all these topics in this subject. So my first aim here is to spend approx 40% of the entire subject time to make you understand finite automatas. So पूरा subject जितना होगा, if I say I can finish this entire subject in 10 hours, then I'm going to spend 4 hours just in finite automatas. If I say the subject is 40 hours, so out of those 40 hours I'm going to spend 20 to 24 hours just in finite automatas. Okay, because if you understand this finite automatas, then only 20-30% time is required to make you understand all of them. If you understood this, 20% time is required to understand all of them, and 10% time or 5% time is required to understand all of them, and rest 40% of your time is required to practice and understand all of them, or you can say 30% here, and last 10% will be to understand your computability and decidability problems. So we'll be starting with the finite automatas. We'll understand what exactly is the finite automatas, what are the various operations you can perform on finite automatas, what are the various conversions in finite automatas. We'll be starting with this finite automatas, and after this we are going to cover this push-down automatas. So second topic will be your push-down automatas, which include both deterministic as well as non-deterministic. Okay. So we are going to study this both push down deterministic and push non-deterministic second topic. That will be your second chapter. So as most of you asked me, sir, how long will what will be the chapters or what are the books, I'm going to tell everything. So just follow through this. तो पहला जो आपका topic है, the first topic is your finite automata. Second topic will be your push down automatas, which include both deterministic as well as non-deterministic. And after studying both of these topics, we'll be studying this as the third topic, which is difference between regular languages and context free language. So this entire topic, regular plus context free, will be your third topic, because if you understood the difference between finite and push down automata and finite automata, then you can easily understand within 5 minutes what is the difference between regular languages and context free languages. And then you will be having the third topic, and your third topic will be your grammar. So sorry, it is your fourth topic, which will be your grammars. So I'm going to make you understand the difference between regular grammar, context free grammar, context sensitive grammar, and unrestricted grammar. We'll try and understand the difference between all of them. Then your fifth topic will be to understand your Turing machines. So Turing machines, as I said, it is of two types. One is your halting Turing machine, then is your just Turing machines which might not be halting. So this will be your fifth topic. And after this fifth topic, I'm going to cover what is the difference between recursive languages and recursively enumerable language. Because if you can create for a language, if you can create a halting Turing machine, then we call that language as recursive. If for a language you can create a Turing machine, that means we call that language as recursively enumerable. So that means every recursive language is recursively enumerable, but every halting Turing machine is a Turing machine, but every Turing machine might not be halting. तो यहाँ पर अगर आप थोड़ा ध्यान से देखेंगे, look at this thing here. So if you look at it here, so you will understand. देखो मैं इसको फिर से एक बार properly समझा देता हूँ. You can understand that if for a language you can create a finite automata, then we call that language as regular. अगर किसी language के लिए आप finite automata बना सकते हैं, then we call that language as regular. If for a language we can create a pushdown automata, then we can say that language is context free. If for a language we can create a Turing machine, then we can say that language is recursively enumerable. If for a language we can create a halting Turing machine, then we say the language is recursive. If for a language we can create a linear bound automata, then we say that language is context sensitive. So these things I'm going to study. So your Turing machine will be your fifth topic, right? And then your this recursive and recursively enumerable languages, both of them will be a part of Turing machine only. And then your sixth topic here in this subject is going to be your decidability and computability. I'm going to take decidability and computability as your sixth topic. Now 40% time will be for finite automata, right? And then you're having 20% time will be given to push-down automatas, linear bound automatas, Turing machines. And then you can see 10% times or 5% time will be given to the grammar, 5 to 10%. And last 5% time will be given to decidability and computability. And this is how much time you are going to require. So entire subject is approximately 40 hours. But I'm going to cover here in these classes this entire subject roughly in 30 hours, 30, 27, 30 hours हमें लगेंगे. So I'm going to cover this entire subject in 27 to 30 hours. And the books that you can refer for this subject is Peter Lin's. For competitive exam, Peter Lin's is the best book, but I feel most of the students will not be able to understand from the Peter Lin's. So the examples that I refer for the subject are from the book Puntam Baker. So you can study this Indian author book Puntam Baker, or you can see there's one more book, many books I guess. I'm not remembering the name. I'll tell you the names also. But if you can understand Peter Lin's, that is more than enough, good enough. But again, if you do not understand, then Puntam Baker you can refer. It is a very, very easy language book. Okay. And this is how we are going to follow all of these topics. Any doubts? So just search Puntam Baker. Yes, KLP Mishra you can refer. So KLP Mishra is a good book. तो आप उसको refer कर सकते हैं. Puntam Baker also you can refer. Any other questions? Is there any questions from anyone? Good. I believe no questions. So now we can start our first chapter here, because this was an introduction chapter. So in the introduction chapter I just covered the overview of the subject की subject में हम लोग क्या करने वाले हैं, the things that we are going to study. Now your first chapter is your deterministic finite automatas. So we'll stop the class here, and then after the break we'll have a break of roughly half an hour to 1 hour. 1 घंटे का break होगा. So after this break we'll again continue. I think the time is 1:30. So we will continue by 2 p.m. तो हम लोग 2 p.m. पे continue करेंगे. It will not be very very long break. Half an hour break will be there. तो ज़्यादा लंबा नहीं रहेगा. At 2 p.m. we will start, and at 2 p.m. we will start with the first chapter, which is finite automatas. Okay. So till then have your lunch, and then we will meet again. So it is 1:30. Have your lunch, and 2 p.m. we will start again. Okay. Which will be your first chapter, which is finite automata. I hope you enjoyed this session. So let's meet in the next session. Great. So we'll continue at 2 p.m. on the same channel.